Where does all that wax go when I burn a candle?
Why, it burns. The long hydrocarbon chains that make up candle wax are transformed into carbon dioxide and water. Candle wax is the fuel for the flame, the wick just helps draw it up to the flame by capillary action.
What causes addiction to a substance?
Drugs that cause addiction change the ability of receptors in your brain to cause you to feel pleasure. There are a few ways this can happen. Depressants often work by increasing the affinity of a receptor for a small molecule called GABA. Gamma-aminobutyric acid. Stimulants make you feel happy or better than you would otherwise. They can do this in a few different ways, but two common ones are to either cause more dopamine to be released or to prevent the reabsorption of dopamine so that it stays around and keeps you happy for longer. Narcotics act in a similar manner to stimulants in that they mimic the molecules that make you happy normally.
What is the inductive effect?
Polarization of a chemical bond due to transmission of charge through other chemical bonds.
When was NMR invented?
The first time NMR spectra were recorded was in 1945, and two different research groups accomplished this independently, one at Stanford and the other at Harvard. These groups were led by Felix Bloch, Stanford, and Edward Purcell, Harvard, who shared the 1952 Nobel Prize in Physics in recognition of their great discovery. See the list of Nobel Prize winners in chemistry in the back of this book. Pound. The location of the peaks along the x-axis is known as the chemical shift, and this value can be related to the electron density surrounding each nucleus. In some NMR spectra, the intensities of each peak, their height on the y-axis, can be related to the number of nuclei of a given element that are present. There are more and more details that one learns after spending lots of time interpreting NMR spectra. But these are the basic principles that allow a chemist to relate an NMR spectrum to a chemical structure.
What is the difference between mass and weight?
Mass and weight are similar terms, but they have slightly different meanings. Weight tells us how much of something there is by telling us how much gravity is pulling down on it. Mass, on the other hand, just tells us how much of something there is, independent of the force of gravity on the object.
What is a reductant?
a reducing agent, or a species that gives electrons to another species.
What is diffusion?
Spreading of something more widely, the movement of a substance from an area of high concentration to an area of lower concentration. The scattering of waves through a space or an object.
How is X-ray diffraction used by chemists?
Chemists use X-ray crystallography to determine the exact structure of chemical compounds. This involves taking a solid crystal of a pure compound and diffracting X-rays off of it, which produces a complex diffraction pattern. Using computer software, the diffraction pattern can be processed to yield a structure that describes the structure of an individual molecule of the compound making up the crystal. This is a powerful technique, but it can only be used on compounds that can be crystallized. It's also worth pointing out that the solid phase structure of a molecule is not always the same as that in a solution. So caution should be used when relating crystal structures to chemical reactivity in the solution phase.
What is diffusion?
Diffusion is essentially the random motion of molecules, or atoms, through a medium. It causes the concentrations of species in a liquid or gas to even out across the accessible volume. Diffusive motions of molecules in a liquid or gas are typically responsible for the chance encounters that lead to bimolecular reactions.
What is a saturated compound?
A molecule with no pi bonds or ring structures.
What is Beer's law?
Beer's law tells us how the amount of electromagnetic radiation absorbed by a sample is related to the concentration of the absorbing species. Beer's law tells us that the absorbance is equal to the length of the sample, L, times the concentration, C, of the absorbing species in the sample, times the molar absorptivity coefficient. In this equation A is absorbance, which is defined as the negative of the logarithm of the ratio of the intensity of light passing through a sample to that incident on it. Basically, this gives us a measure of how much light a sample is absorbing and how much light is passing through it.
What is emulsion?
Non-superimposable mirror images.
What is quantum mechanics?
the branch of physics that describes the motion and interactions of subatomic particles.
What gives a substance its color?
The color of a substance is the combination of the light that is reflected back at your eye. In other words, you're seeing the light that is not absorbed by the substance. Certain frequencies can be absorbed because of the electronic structure of a substance, while others simply bounce off back into your eye.
If cooking spray is just oil, then how can it have 0 calories and no fat?
Cooking spray lets you apply a thinner layer of oil than you could probably achieve by pouring normal liquid vegetable oil out of a bottle. The FDA states that any food substance with less than 5 calories and less than 0.5 g of fat per serving can be labeled calorie-free and fat-free, respectively. So manufacturers of cooking spray adjust the recommended serving size to contain less than those limits. As a result, your can of spray contains hundreds of servings. Go check your pantry if you don't believe it.
What is removed from butter to make clarified butter?
Proteins and water. Clarified butter is made by melting regular butter at a low temperature. 3 layers will form. The top frothy layer contains the proteins from milk, casein. Used to make cheese, the middle layer is water with dissolved milk sugars, like lactose. The bottom layer is pure butterfat or milk fat, which is also known as clarified butter. You can instead heat butter at a low temperature for a long time to remove the water by evaporation, and then decant or filter the butterfat. Clarified butter contains almost no proteins, so it has a very long shelf life. And no lactose, so people who are lactose intolerant can eat it.
What is the Mohs scale of hardness?
Substances, mostly minerals, are ranked by their ability to scratch one another. If one mineral can scratch another mineral, it gets a higher ranking on the Mohs hardness scale. When Friedrich Mohs devised the scale, diamond was the hardness substance known. So it was given a value of 10. Talc, also known as talcum powder, being very soft, has a hardest rating of only 1. Mohs devised this scale to help sort out the private rock collection of an Austrian banker, and later the Archduke's Museum collection. There are more quantitatively accurate measurements of hardness available today, but the simplicity of the Mohs scale keeps it relevant and practical.
How does materials science help to improve the fuel efficiency of your car?
One way is through better tires. There are currently tires in development made of rubber that rolls along with less resistance, which has the potential to improve gas mileage by as much as 10% just through the tires. Another way involves using special lubricants that work well at a wider range of temperatures, allowing for better fuel efficiency even when the engine is cold as well as when it's warm. This also has the potential to improve fuel efficiency by about 6%. Additionally, materials science is also the field responsible for developing lightweight materials to construct all of the components of a vehicle, which further contributes to improving vehicle fuel efficiency.
What effects cause deviations from the ideal gas law?
Deviations from the ideal gas law occur due to intermolecular forces between the gas particles as well as the fact that gas particles do actually occupy volume. There is a modified version of the ideal gas law, see atoms and molecules, called the van der Waals equation of state, that uses constants specific to each molecule or atom to adjust for these factors. Deviations from ideal gas law behavior become more important at relatively high pressures and or low temperatures.
What is saponification?
Technically the hydrolysis of triglycerides, i.e., triesters, with sodium hydroxide, more generally refers to hydrolysis of any ester.
Why do polar bears have black skin and clear fur?
There is some debate on the subject, but the combination of black skin and clear fur is probably the best for keeping the polar bear warm while not giving away its position when hunting. The black color of the skin is the best for absorbing energy from the sun. Objects that appear black don't reflect any wavelengths of light. The clear fur allows that light to get to the skin, but still looks white so the bear can blend in with the surrounding ice and snow. A few years ago, or maybe you heard this recently because it has achieved urban legend status. A rumor you may have heard is that polar bear fur is actually like a fiber optic network for harnessing or focusing sunlight toward the bear's skin. While this would have been cool, it's unfortunately completely bogus.
What is a reaction?
The process of changing chemical bonds in a molecular or ionic compound.
What is genetic engineering?
Genetic engineering is the process of changing the genetic makeup of cells or organisms. to produce versions with specific traits or to produce new organisms altogether.
What is a glove box and what is its purpose?
A glove box is a method of carrying out chemical reactions under an inert atmosphere. It basically consists of a large box that has had the air removed and replaced with an inert gas, like pure nitrogen or argon. One side of the box is typically made of a clear, hard, transparent plastic, which has openings covered by large rubber gloves, into which a researcher can insert their arms. This allows a researcher to manipulate items inside the inert atmosphere of the glove box without letting any air inside. To move items in or out of the box, a purgeable antechamber is attached to one side of the box. While it is certainly not as easy to manipulate items inside a glove box as it is to manipulate items outside the box, a glove box provides one of the most straightforward approaches to carrying out chemistry in an air-free environment.
Why can't I put raw eggs in the freezer?
You can if you take them out of their shells. Raw eggs expand when frozen, which can break the shell, so don't put whole eggs directly into the freezer.
What is scanning electron microscopy?
Scanning electron microscopy, SEM, is a technique used to capture a picture of a sample by focusing a beam of electrons onto the sample, scanning the beam around the surface of the sample, and then detecting the electrons after they have been scattered off of the sample. The scattered electrons are then analyzed to produce an image of the sample. In general, imaging methods that make use of electrons can offer higher resolution than those based on light due to the shorter wavelengths associated with electrons, as opposed to photons. SEM can be used to obtain very high-resolution images of a sample on length scales as short as 1 nanometer. The downside to electron-based methods, again, as opposed to using light, is that the electron-based methods are often damaging to the sample, especially to live samples. Whereas shining a beam of light on a sample doesn't typically cause a lot of damage. SEM has been useful for characterizing materials as well as a wide range of other kinds of samples.
What is an addition reaction?
In an addition reaction, two or more molecules combine to make one molecule. This is different than the substitution reactions we have been looking at, where two molecules combine to make two different molecules. The addition of an acid to an alkene is the simplest example. Here, an acid protonates a carbon-carbon double bond. The carbocation that is formed will be the more substituted one of the possible products that could form. The conjugate base of the acid then reacts with this carbocation.
What are supercritical fluids, and why can these be useful as green solvents?
A supercritical fluid is a substance that has reached sufficiently high temperature and pressure to be beyond a critical point on the phase diagram. See macroscopic properties. This critical value of temperature and pressure will be different for each substance, and it corresponds to a set of conditions beyond which the distinction between the liquid and gas phases of matter is no longer clear. That is to say, beyond this value, the density and other properties of the substance can be changed continuously and readily, with changes in the temperature and pressure of the system. This makes for useful green solvents because having the ability to tune the density, solubility properties, and diffusivity of the supercritical fluid allows for reaction or extraction conditions to be sensitively manipulated. Let's consider one supercritical fluid that has drawn particular interest, carbon dioxide, or CO2. Some of the advantages of CO2 as a supercritical fluid are that it cannot be oxidized. It is aprotic, and it does not tend to participate in reactions involving free radicals. This makes carbon dioxide robust toward undergoing chemical reactions itself. And it also means that it is relatively benign as a contaminant, ignoring its role as a greenhouse gas, for the moment. However, CO2 is a gas at ambient temperature and pressure, and thus, to serve as a good solvent, it must be used at elevated pressures and/or temperatures. At varied temperatures and pressures, supercritical CO2 is also capable of dissolving a wide range of chemical compounds and is miscible with gases in almost any proportion. Supercritical CO2 can also often be recycled as a solvent, and thus does not tend to generate large amounts of waste. Indeed, carbon dioxide can also be used as a solvent in its liquid form, but it then loses several of the advantages with regard to the tunability of its properties that we mentioned above.
Why did Adolf Friedrich Johann Butenandt, Germany, win the Nobel Prize for Chemistry?
For his work on sex hormones, and Leopold Ruzicka. Croatia, for his work on polymethylenes and higher terp-NS. Butenandt was the first to isolate and crystallize a compound with the characteristics of a male sex hormone by extraction from male urine. Butenandt characterized the chemical formula of this complex, and called it androsterone. It was then discovered that this compound was actually slightly different from testosterone. But Butenandt and Ruzicka were both able to synthesize testosterone from androsterone. Ruzicka synthesized the same compound, androsterone, that Butenandt isolated from male urine. he too was able to convert it into the male sex hormone testosterone. Ruzicka also worked to synthesize and characterize polyterpene complexes that are related to physically and biologically important compounds, including sex hormones. Ruzicka's work contributed greatly to the knowledge surrounding sex hormones, which, of course, are very important physiologically. And his work thus laid the ground for future investigations into the roles of these complexes.
How is a condensation polymerization reaction different?
Addition polymerization reactions do not involve the loss of any atoms from the monomer. But condensation polymerization reactions do. The molecule that is lost is almost always water.
What is anhydrous?
Without water.
What are a couple of examples of familiar chemical reactions?
Fire is one example of a chemical reaction that everyone has seen take place. Fire involves a combustion reaction, which is any reaction where a hydrocarbon reacts with oxygen to form carbon dioxide and water. Another example is when your car accumulates rust. This reaction involves oxidation of the iron in the metal. Lots of complicated chemical reactions are taking place all the time in our bodies too. Every movement you make, for example, involves many chemical reactions taking place in your muscles and nerves.
What is a molecule?
A molecule is a set of atoms held together by chemical bonds. Molecules are the smallest units of a substance that behave as that substance. And separating the atoms of a molecule will change its properties.
What is hapticity?
Number of contiguous atoms coordinated to a central atom.
What is a chemical reaction?
A chemical reaction is any process that involves the transformation of one or more molecules into one or more molecules. Most of the time the reactant, S, and product, S, will be different molecules. A chemical reaction almost always involves the breaking and or formation of new chemical bonds.
What is a physical change?
A physical change is a change involving the macroscopic properties of a substance without any accompanying change in chemical composition. A few examples of physical changes would be evaporating, melting, cutting, slicing, breaking, and grinding. The key similarity is that none of these processes involve changing the chemical makeup of the substance.
What is a syntactic polymer?
A polymer in which substituents are located on alternating sides of the backbone.
Why did Irving Langmuir, United States, win the Nobel Prize for Chemistry?
For his discoveries and investigations in surface chemistry. As a graduate student, Langmuir studied light bulbs, and then went on to improve vacuum pump designs. These two interests merged, in some respects, and Langmuir was able to invent the incandescent light bulb. These led to his interest in surface chemistry, after observing that a tungsten filament, like those in a light bulb, could split H2 on its surface, forming a single atomic layer of hydrogen atoms. The work of direct relevance to his receiving the prize, however, was his study of thin films of oil and surfactants on the surface of water. Langmuir postulated that the molecules of surfactants would orient themselves into a layer that was a single molecule thick. He went on to develop the physics to describe such thin layers, which would eventually be known as monolayers.
What is the reaction rate?
How fast the reaction takes place. Typically measured in terms of a change in concentration of a chemical species with respect to time.
Why did Derek H. R. Barton, United Kingdom, and Odd Hassel, Norway, win the Nobel Prize for Chemistry?
For their contributions to the development of the concept of conformation and its application in chemistry. Barton and Hassel earned the prize for their work surrounding the conformational analysis of molecules. While we draw a molecule on paper in a specific orientation and conformation, there are, in truth, typically many accessible conformations to a given molecule. This is especially true for floppy molecules. And these are where conformational analysis can be particularly insightful and important. Their work drew attention to the importance of rotations and other conformational changes in chemistry, particularly with regard to organic molecules. They showed that reactivity can actually be significantly influenced by the conformation of a molecule, and that conformational changes may be necessary to promote reactivity or allow for a reaction to take place. Why did Louis F.
How do the boiling point and melting point of a substance change as a solute/impurity is added?
The addition of a solute typically raises the boiling point and lowers the melting point of a substance. These effects are appropriately named boiling point elevation and melting point depression. Boiling points are raised when a nonvolatile solute, like NaCl, is added to a solution because the solute lowers the vapor pressure of the solution. That is a somewhat circular explanation though. It is important to know that this change in boiling point does not depend on what you add to the liquid. So there are no specific interactions going on here, like forming hydrogen bonds, etc. As long as the solute has lower vapor pressure, remember we said it was nonvolatile. So its vapor pressure is essentially zero, this effect will be present. It is perfectly correct to think about it as just lowering the vapor pressure of the mixture. If you add something with very low vapor pressure, the average vapor pressure of whatever liquid you're adding it to will go down. Melting, or freezing, points are usually lowered when a solute is added to a liquid. The best explanation for this effect is based on entropy, see physical and theoretical chemistry. When a molecule of solvent moves from the liquid to the solid phase, freezes, the amount of liquid solvent, i.e., its volume, is reduced. This means the same amount of solute is in a smaller space, which reduces their entropy, or raises their energy. This raising of energy means that you have to take even more energy out of the system for each molecule that joins the solid phase. Less energy means lower temperature, so adding a solute lowers the freezing point. An alternative way to look at this is that any impurity will disrupt the crystal lattice, raising its energy, relative to the liquid phase. This also contributes to lowering the freezing point as solutes are added.
Why did Robert S. Mulliken, United States, win the Nobel Prize for Chemistry?
For his fundamental work concerning chemical bonds and the electronic structure of molecules by the molecular orbital method. Mulliken received the Nobel Prize in recognition of his work studying that nature of how electrons behaving in molecules. In particular for the molecular orbital approach that he developed. Molecular orbitals are formed by the overlap of the orbitals on individual atoms. And these can be used to rationalize whether bonds will exist between pairs of atoms. How strongly the pairs will be bonded, and what type of reactivity the molecule may be expected to undergo.
What is glue?
There are many different types of adhesives. But you're probably thinking of that white glue you had as a kid. This type of glue is known as a drying adhesive because it hardens by evaporation of a solvent. In the case of white glue, the solvent is water and the sticky stuff that gets left behind is polyvinyl acetate.
Does metal rust in outer space?
Sort of. Rusting in outer space doesn't happen in quite the same way it does on Earth due to differences in the amount of available water. On Earth, iron rusts when it interacts with water molecules, causing oxidation of some of the metal atoms to metal oxides. Recalling this information, it is clear that some source of oxygen atoms must be present for metal to rust. There is very little oxygen or water floating around in outer space, so the reaction doesn't proceed as quickly or via the same mechanism. Actually, in outer space, the very small amounts of oxygen, O2, or water, H2O, that are around are believed to undergo photochemical reactions with metals to produce metal oxides, like rust, Fe2O3. Scientists can get a sense of how rapidly metals rust in outer space by looking at iron-containing meteorites that reach the Earth.
How much space does an atom occupy?
The atomic radius of the smallest atom, hydrogen, is 53 × 10 to 12 meters, so it is about 10 to 10 meters in size. The atomic radius of the largest atom, cesium, is about 270 × 10 to 12 meters, or roughly 5 times that of hydrogen. These are all very, very small sizes.
What is a chalcogen?
A chalcogen is an element in group 16 on the periodic table. This includes oxygen, sulfur, selenium, tellurium, polonium, and livermorium. This name comes from the Greek word meaning copper former, and has its origins in the fact that some of these elements tend to coordinate to metals to form compounds with metals in ores.
What packing arrangements are possible for a crystal lattice?
There are 3 basic packing arrangements, which we can describe by again imagining a tiny box. If we place an atom at each of the 8 vertices of this box, the arrangement is referred to as simple cubic. If we take a simple cubic unit cell and add an atom to the center of each face, we have a face-centered cubic arrangement. If we instead add an atom to the center of the cube, it's called a body-centered cubic unit cell. There are more possibilities, but these 3 simple ones described here cover a lot of the crystals that chemists encounter.
What is a mole fraction?
The amount of a substance in moles divided by the total number of moles present.
What are the transition metals?
Elements in the D block, groups 3 to 12, of the periodic table are referred to as transition metals. The lanthanides and actinides are usually excluded. With the exception of group 12, the transition metal elements have an incomplete d shell of electrons. The chemistry of these elements depends strongly on these d electrons. And most transition metals are stable in multiple different oxidation states. If the metal has any unpaired d electrons, it can have magnetic properties. Many transition metals have uses as catalysts in bond-forming reactions. And we'll talk about a few later in this chapter.
What is an organic compound?
Any molecule, or compound, that contains carbon atoms is referred to as organic. The usage of this term is a bit arbitrary, though, as some forms of carbon, like graphite and diamond, and carbon-containing ions, like formate and carbonate, are not thought of by chemists as organic molecules.
What is a liquid-liquid extraction?
Extract ions are techniques used to separate the components of a mixture based on their solubilities in different media. A liquid-liquid extraction specifically uses two immiscible liquids to separate the components of a mixture. Two liquids are placed in the same container and shaken vigorously to allow the dissolved components to equilibrate between the two liquid phases. One liquid can then be drained from the container, and the solvents can then be evaporated to recover the separated components of the mixture.
What is the sun made of?
The Sun is made up of extremely hot gaseous elements, primarily hydrogen and helium. There are also small amounts of oxygen, nitrogen, carbon, neon, iron, silicon, and magnesium. Because it is so heavy, the Sun produces an extremely strong gravitational pull, which leads to very high pressures and temperatures, especially near the Sun's core. Roughly 27 million degrees Fahrenheit, or 15 million degrees Celsius. These extreme conditions can cause two hydrogen atoms to undergo fusion. See nuclear chemistry, to create a helium atom. The other two parts of the Sun are the radiative layer, the middle layer, and the convective layer, the outermost layer. Below is a table listing the relative abundance of elements in the Sun. In total there are at least 67 elements that have been identified as being present in the Sun. This table lists the 10 most abundant ones.
Who ran the first chemistry experiment ever?
Jaber ibn Hayyan, known as Geber in Western texts, was probably the world's first alchemist to run actual experiments. Jaber lived during the 8th century in what is now Iran, and like alchemists before and after him, was fascinated by the prospect of changing one metal into another and by creating artificial life. To Aristotle's 4 elements, Jaber added sulfur and mercury, and proposed that all metals were made of differing ratios of these 2 elements. He was the first to emphasize the importance of rigorous experimentation, and is credited with describing many common lab techniques and equipment.
Why are scientists so interested in semiconductors?
Recall that semiconductors are a class of materials defined by their conductivity properties. Specifically, they have intermediate conductivity properties between those of things that conduct extremely well, like metals, and things that don't tend to conduct well at all, insulators. This is what makes them so useful. Scientists are able to use semiconductors to control the flow of electricity in circuits, which has been crucial for the development of all of the complicated electronic devices you're familiar with. Semiconductors can be doped with materials containing extra electrons, or with materials that are electron deficient, to control the direction of electron flow through the material. Semiconductors have also played a big role in developing solar energy capture devices. The amount of energy a semiconductor needs to absorb to release an electron such that electricity can flow can be finely tuned, allowing scientists to develop materials capable of storing solar energy from photons of light, in the form of electricity.
What is a cathode?
Electrode where reduction occurs.
How was the modern periodic table developed?
A French geologist named Alexandre Biguier de Chancourtois is actually the first on record to list all of the elements in order of increasing atomic mass. His first version contained 62 elements and they were placed in columns that wrapped around a cylinder. However, there were a variety of issues with this first attempt that were later improved upon. Newlands made the next significant advance, publishing the elements in columns of those with similar properties, which brought the description close to the version chemists use today. The modern version of the periodic table was proposed by a Russian scientist named Dmitry Mendeleev in 1869. His table was the first to lay out the elements in order of increasing atomic mass in columns of elements with similar reactivity. Elements on the table appeared periodically. essentially in accordance with the law of octaves, hence the name the periodic table. Mendeleev's table had to include some blank spaces so that the elements were each in the proper column according to reactivity. As more elements were discovered, the blank spaces in the table were eventually filled in, validating Mendeleev's table.
What is a calorie?
A unit of energy equal to 4.184 joules.
What is scientific notation?
Scientific notation is a commonly used method for expressing large numbers. The number is written as a product of a decimal number and a power of 10. See the following question for an example of where this is useful.
What is infrared?
Electromagnetic radiation with wavelengths of 750 nanometers to 1 millimeter. Just longer than the visible spectrum, but not as long as microwave radiation.
What is a glass?
An amorphous solid material.
What is the collision frequency?
Average number of collision events per second.
Why did George A. Allah, United States/Hungary, win the Nobel Prize for Chemistry?
For his contribution to carbocation chemistry. Carbocations are species that contain one or more positively charged carbon atoms. While these types of intermediates were postulated for years to play key roles in organic reactions, it was never believed that they could be isolated, due to the fact that they should be highly reactive. Allah managed to prepare stable carbocations through the use of extremely acidic compounds, which are actually called superacids. Allah's work thus revolutionized research into carbocation chemistry, as these species could finally be characterized for the first time. This work has been very influential in better understanding the role of these important intermediates in organic chemistry.
Weight-absorbent polymers are also used to chill drinks? How does that work?
If you stuff a cup holder with absorbent polymer and then soak it in water, the polymer will obviously swell up. The water will slowly evaporate out of the polymer, which reduces the temperature of the polymer gel and ultimately your drink.
What do the different octane ratings mean at the gas pump?
The octane number provides a measure of the amount of compression a fuel can undergo before it combusts. The name octane rating comes from the fact that isooctane is used as the standard against which a fuel's compression characteristics are measured. A fuel with an octane rating of 89 means that it has the same ability to withstand compression as a mixture of 89% isooctane and 11% heptane. In reality, gasoline contains many other components. Fuels with higher octane ratings are typically used in higher performance automobiles. Since fuels may be able to withstand compression better than isooctane, it's entirely possible to achieve octane ratings of over 100.
What is a phosphodiester bond?
Phosphodiester bonds are what make up the backbone of DNA and RNA molecules. These bonds provide the linkage that holds together the individual nucleotides or nucleosides in DNA and RNA. Enzymes called polymerases catalyze their formation, DNA polymerases for DNA and RNA polymerases for RNA. Take a look at the picture below to see the chemical structure of a phosphodiester bond.
How does a battery work?
Batteries operate based on chemical redox reactions that are set up to cause the spontaneous flow of electrons through the object you want to power.
How far away can one molecule feel another?
Molecules feel one another through the intermolecular forces they exert on one another. These typically span lengths that are a little longer than the length of chemical bonds, or something in the neighborhood of 5 × 10 to 10 meters.
How many nuclear power reactors are there in the world, and how many are currently under construction?
There are currently 436 nuclear power reactors around the world. The breakdown of the distribution by country is shown in the table below. Aside from the United States, a few other countries with large numbers of nuclear reactors are France, Russia, China, Japan, and Korea. Each of these nations has at least 20 nuclear reactors currently in operation.
How are transition metals important for nitrogen fixation?
Nitrogen fixation is the term for a process that converts diatomic nitrogen gas N2 in the atmosphere into ammonia, NH3. This is a very important biological process because it converts N2, which is very unreactive, into a form that can more readily be incorporated into amino acids and other molecules. Transition metals, such as vanadium or molybdenum, are found in the active sites of the enzymes that carry out this important reaction.
What is fire?
The chemical description of fire is a combustion reaction. It involves the reaction of oxygen with molecules in some combustible material. The fire itself is caused by energy released by this reaction in the form of heat and light. The fire you see is not only the light that's being released, but also glowing hot gases.
What is an electron?
Fundamental particle with a negative electric charge.
What is a heteroatom?
A heteroatom is any atom that is not a carbon or hydrogen atom. Some examples of typical heteroatoms include oxygen, sulfur, nitrogen, phosphorus, chlorine, bromine, and iodine, though anything other than carbon or hydrogen fits the definition.
How was oxygen gas first discovered?
Well, to answer that question, you would first want to know who first discovered oxygen. And there is no simple answer to that question. There are three people to whom discovery of this can be ascribed: Carl Wilhelm Scheele, Joseph Priestley, and Antoine Lavoisier. Scheele produced O2, he called it fire-air, from mercuric oxide, HgO. In 1772, but the result wasn't published until 1777. Meanwhile, in 1774 Priestley produced O2, he called it dephlogisticated air. Using a similar experiment, which was published in 1775, Lavoisier claimed to have independently discovered the gas, and was in fact the first to explain how combustion worked via quantitative experiments, leading to the principle of conservation of mass, and ultimately disproving the entire idea of phlogiston. WIO. So Scheele found it first, but didn't report it. Priestley reported it first, but didn't have the explanation correct, and Lavoisier was last, but nailed it. Who would you give credit to?
What is the boiling point?
Temperature for a given liquid at which its vapor pressure is equal to the external pressure acting on it.
What herbal medicines do people still use today?
Aspirin and quinine are probably the most famous herbal medicines that have made the transition to mainstream medicine. Many modern medicines were originally isolated from plants. However, but the commercial sources are now usually man-made. For example, Taxol, R. paclitaxel, was originally isolated from the Pacific yew tree. In 1967 this compound was found to be useful as a treatment for various types of cancer. For almost 30 years, most of the paclitaxel that was given to patients was obtained from the yew tree. Alternate supplies of this drug were developed in the 1990s. Moving this natural drug into the realm of modern synthetic medicines.
Does hot water really freeze faster than cold water?
Sometimes. This observation is known as the Mpemba effect, named after the Tanzanian student who in 1963 resurrected the idea from Aristotle, Francis Bacon, and René Descartes. Whether or not this effect can be seen seems to depend on so many variables, the size and shape of the container, the initial temperatures of the two liquids, the method of cooling, on how you define freezing, when the first ice crystal forms, when there's a solid layer on the top, or when all of the water has frozen solid, that it's really still unclear if this effect is real or not.
What is a gram?
One slash 1,000 of a kilogram, which is the standard unit for mass.
Can anything travel faster than the speed of light in a vacuum?
No, or at least it's presently thought that this would be impossible. It's interesting, though, that there have been a couple of experiments in recent years which have observed particles called neutrinos moving faster than the speed of light. Even the scientists who carried out these experiments questioned the results. However, and they encouraged others to try to confirm their results, or to find where a mistake might have been made in their measurements. In the end, they did find out that these results were caused by a mistake. There was a loose electrical cable that caused enough error to invalidate the results.
What is fiberglass?
Fiberglass is a polymer made from a plastic matrix that is reinforced by fibers of glass. It is a popular material because it is inexpensive to make and its strength and weight properties compare favorably against those of metals for many applications. Fiberglass has a wide range of applications and is commonly used in glider aircraft, boats, cars, showers and bathtubs, roofs, pipes, and surfboards.
What pollutants do coal power plants generate?
Burning coal introduces pollutants such as nitrogen oxides, sulfur dioxide, and mercury into the atmosphere. A large amount of carbon dioxide. The principal pollutant implicated in global warming is also produced by coal power plants. Aside from global warming, many of the pollutants from coal power plants are bad for human health and also cause smog, soot, and acid rain. The solid waste produced by burning coal can also be harmful to the environment. The ash from coal power plants is typically composed of about 5% pollutants or dangerous substances such as arsenic, cadmium, chromium, lead, and mercury. This can also cause pollution in water if it is not disposed of properly. And there have been many cases of water contamination caused by improper disposal of this ash.
What is AGEL?
A semi-solid suspension of a solid in a liquid, a type of colloid.
What makes a reaction happen spontaneously?
A spontaneous chemical reaction is one for which the associated change in Gibbs free energy is negative. The fact that a reaction is spontaneous actually doesn't tell us anything about how quickly the reaction takes place, though. A spontaneous reaction may happen very quickly or take thousands of years.
So why do opposite ends of magnets attract or repel one another?
Remember that real-world magnets are ferromagnetic substances. They have a net overall spin. Again, this is a quantum mechanical spin, but it's okay to think of it as spin up or down. In a ferromagnet, all of these spins are pointing in the same direction. If you put the up ends of a magnet together, they will repel. The magnetic fields are pushing in opposite directions. If you put an up end next to a down end, they will attract. The magnetic fields are working in the same direction. Just like the electron spins are aligned within the magnet.
What is the hardest material in your body?
Tooth enamel is the hardest material in your body. It's even harder than bone.
What is atomic emission spectroscopy, EES?
AES measures the wavelengths of light that are emitted, or absorbed, when a sample is burned. The wavelengths of the spectral lines are unique to each element because the energy of the photon released from the atom depends on the electronic structure of the particular atom.
Can cold weather really cause a cold?
This actually is not true. Colds are caused by a virus that must enter your body to cause cold symptoms. Contracting the cold virus really has nothing, directly, to do with cold weather. The only reason colds seem to be more prevalent during colder seasons is that people spend more time indoors, placing them in closer proximity to one another, which makes it easier for the virus to spread between people.
What's special or different about organic foods?
While the precise definition is still changing, everyone agrees that organic foods are those grown without the use of pesticides or synthetic fertilizers. The organic label also frequently excludes the use of irradiation and genetically modified fruits and vegetables. Whether the food tastes better, or is healthier to eat, is for you, or at least someone other than us, to say.
What is PP, polypropylene?
If instead of substituting a chlorine atom we add a methyl group to each ethylene monomer, we get polypropylene. Recall from earlier that this introduces stereochemistry along the polymer. We've already mentioned that the arrangement of the methyl groups along the polymer chain can have large effects on the melting point and other physical properties. You can likely find polypropylene all over your house, from dishwasher-safe food containers to synthetic carpets, especially outdoor carpeting, and an increasing weight fraction of your car, including the bumper and the casing for the battery. It can also be made into ropes, which are quite strong and resistant to weather. So they are frequently used in fishing and farming. Polypropylene is also used for many medical applications because it is capable of withstanding the high temperatures required to sterilize.
What is a racemic mixture?
A racemic mixture contains equal amounts of both enantiomers of a molecule.
What is a thermoset?
Unlike a thermoplastic, Thermoset materials are cured such that they don't soften when exposed to heat. At least up to a certain point. This curing step usually introduces a lot of cross-links between polymer chains, which creates a rigid network. These materials are much more difficult to recycle, but are used where high temperature stability is needed.